Okay, today we'll be learning about translations and vectors. So I have these already placed in there, but we'll talk a little bit about them. A translation is a transformation, which we've already talked about, that maps every 2 points, so P and Q, in the plane to points P prime and Q prime, so that the following properties are true. So they must have these properties in order to be a translation. So P prime should have the same distance as Q prime. And also P prime should be parallel to Q prime, or P prime and Q prime are collinear. So those are some properties that make it a translation. And the theorem 7.4 just states that a translation is an isometry. That means it doesn't change angles or anything like that. Okay, let's look at theorem 7.5. If lines K and M are parallel, so we have line K here and line M there, then a reflection in line K, so we're starting with QP, and you reflect it over K, is called, and then followed by a reflection over M, it becomes a translation from QP to Q double prime to P double prime. If P double prime is the image of P, then then the following is true. So you have P to P prime is perpendicular to K and M. So if we draw a line from P to P double prime, then we see that it is perpendicular right there. Also, P to P double prime equals 2D. That means the distance between K and M. So if D were 5 units, then P to P double prime would be 10. Okay, let's move on. All right, so here's an example. In the diagram, a reflection in line K maps GH, so we're starting here with GH, right there, to G prime, H prime, right here. And then also it's reflected over DC, which gives us H double prime and G double prime. KM, so K and M are parallel, and HB is equal to 5, and DH is equal to 2. And it says to name some congruent segments. Let's first start looking at this. If we know that from here to here is a reflection, then we know that HB is going to be equal to H prime. So we know this will be 5. Now we have H prime being reflected over DC to give me H double prime. We know that from D to H double prime it's 2, and that means that from D to H it's 2. I'm sorry, D to H prime it's 2. Okay, and we also know that our GH is going to be congruent to our HG and to our our GH is going to be congruent to our H prime G prime, and is also going to be congruent to our H double prime G double prime, because they're the same segment, they're just being reflected and translated. So let's look at what they want us to do. So A, name some congruent sides. So we're just going to name a few. So we did say that GH and G prime H prime and G double prime H double prime were congruent. Those are a set of congruent statements. And then we also know that HB is congruent to H prime B. And then also we have H double prime D is congruent to H prime D. So we can put that one too. We can say that H prime D is congruent to H double prime D. So those are some congruent segments. We could also go on the bottom and do those, but those are just examples of some. Okay, B. Does AC, so we'll find AC right here, equal BD? And the answer to that is yes, because they're opposite sides of a rectangle. So we have opposite sides of a rectangle, and we know that opposite sides of a rectangle are congruent. Now let's look at C. What is the length of G double prime? So we already mapped out all the ones on the top, and we know that it's going to be the same on the bottom. So we just need to add 5 plus 5 plus 2 plus 2, which are all the lengths on top from H to H double prime. And that's going to give us 14 units. Okay, now let's do translations in a coordinate plane. So first I need to attempt to do a coordinate grid on here. It's a little hard, remember, on this program, but I will try my best. Okay, so now I have my coordinate grid. I'm going to do point A. So I have -1, -3. So I'm going to be right there. And I'm going to label that A. Okay, and then I have B, which is over 1, down 1 right here. So that's point B. And then I have C, which is -1, 0, so it's going to be right there. So I'm going to make this C. This is going to be a triangle. So I map my triangle. Then sketch the image of the triangle after the translation. So when this means x minus 3, that means for all your x coordinates, you're going to subtract 3 from that, or you're going to go to the left 3 values. So I'm going to go to my x's, and then also for the y, it looks like we're adding 4. So for A, I have -1, but I'm taking away 3, so it's going to become -4. And then I have -3, but I'm going to add 4, so it's going to become 1. Now, or that's A prime. And then B prime, I'm going to take away 3, so that would be -2, and then I'm going to add 4, which would give me 3. And then C prime is going to be, we take 3 away from -1, so I get -4, and then I add 4 to 0, so I get 4. Let's plot our points and see what happens. So I'm going to go over -4, so I go 1, 2, 3, 4, and then up 1, and that's point A. And then I'm going to do -2, 1, 2, up 3, 1, 2, 3, and that is B. And then I have C prime, which is -4, and then up 4, 1, 2, 3, 4, and that's C prime, B prime, A prime, and here is my new triangle that was translated. So you just change the coordinates according to the rule that they give you. Okay, so let's look at one more example, because we're going to talk about vectors. Another way to describe a translation is by using a vector. And we talked about this in science a little bit. A vector is a quantity that has both direction and magnitude or size, and is represented by an arrow drawn between 2 points. The diagram shows a vector, so that PQ is your vector. The initial point, the starting point, is P. And the terminal point, the ending point, is Q, because that's where the arrow points to. The vector is named PQ with an arrow over it. Kind of looks like a ray, which is read as vector PQ. The horizontal component of vector PQ is 5. So horizontal means you're moving right down here. And then the vertical component of vector PQ is 3. The component form of a vector combines the horizontal and vertical components. So the component form of vector PQ is 5, 3. And notice you don't put parentheses, you put these symbols. Okay, in the diagram, name each vector. So my initial point is J. So I know my vector is going to look like, whoops, changed my colors. So my vector will look like this. And I want to know what the magnitude of the vector is in direction. So I'm going to go from this point to that point. So I'm going to the right 1, 2, 3. So I know that one goes first. And then I'm going to go up 1, 2, 3, 4. So that vector is 3, 4. Now for B, it starts at M and goes to N. So I have my arrow. The vector is going to be, we don't go over any, so we have 0, and we're going up 4. So that's the vector for that one. And now vector TS, because the arrow is at the S, we're going to start at T, and we're going to drop down. So we're starting at T, we go over 1, 2, 3. So it's a positive 3 to the right. But then we're dropping 1, 2, 3 down. So it's negative 3 down. So you start at your initial, and then you go over and down. Okay, and that should be it for tonight. We will add more to this unit when we get to it. Thank you.